Hello, fellow chemists. In this video, we're going to take a look at atomic mass. And then we're going to also make sure that we clearly understand the difference between the terms atomic mass, atomic number, and mass number. This is labeled as an intermediate level video because it assumes that you understand the basics of atomic structure. It also assumes that you understand the terms atomic number, mass number, and isotopes. If you need a review on those topics, I will put a link in the upper right-hand corner. So let's talk about what atomic mass is. The first thing that we're going to do is go over the basic definition of it. But then usually for atomic mass, for students to really understand it, they need to see some examples of that definition. So let's start off by just putting the definition up there. So atomic mass is the weighted average mass of all isotopes for an element. And the atomic mass is shown on the periodic table. Now, usually when I just give students this definition in a class, they kind of look at each other and like, what does that mean? So let's kind of go through and make sure that we're real comfortable with this term weighted average means, so that you really understand what we're talking about when we're looking at average mass of isotopes. So to better explain the definition of atomic mass, let's go through an example. And the example we're going to do is my favorite element. We're going to take a look at carbon. Now, carbon exists in two stable types of isotopes, carbon-12 and carbon-13. So if we draw the symbol for carbon-12, remember this number at the bottom is the atomic number. That's the number of protons. And this number up here in the upper left is the mass number. That's the number of protons plus the number of neutrons in the atom. And then we draw carbon-13 over here. So carbon-12 will have 6 neutrons, and carbon-13 has 7 neutrons in it. Now, if we looked at how much carbon-12 and carbon-13 weigh in atomic mass units, carbon-12 is going to weigh 12 because you add up all the numbers of protons and neutrons in the atom. Carbon-12 has 6 protons and 6 neutrons. And carbon-13 is going to weigh 13 because it has 6 protons and 7 neutrons. The next thing we need to know, and this is very important for looking at and calculating atomic masses, is we need to know their percent abundance. And carbon-12, 99% of all carbon in the universe exists as carbon-12, and 1% of carbon in the universe exists as carbon-13. Now, these percent abundances are not something that you're going to be able to just see on most periodic tables. It's something that you're going to need to look up. So if we wanted to find the average mass of carbon, well, let's kind of think about this. If I randomly grabbed 100 carbon atoms in the universe, 99 of those carbons are going to weigh 12, and only one of them is going to weigh 13. So the average mass of carbon is going to be just a little bit above 12. That's why we must take the weighted average. That's because not all isotopes exist in the same percentage. So to calculate out what the weighted average mass of the isotopes is for carbon-12, you just take the percentages and convert it into decimals. So we have 0.99, and then you multiply that by its mass times 12. And 0.99 times 12 comes out to 11.88. And then there's 1%, so that would be 0.01, and that that 1% of carbon weighs 13. So 0.01 times 13 comes out to 0.13. and you add up all these pieces here. So 11.88 plus 0.13 comes out to 12.01. Well, 12.01 should be the atomic mass for carbon because it's the average mass, and we took into account the weight of the isotopes, the percentages of the isotopes. So let's take a look on the periodic table. We zoom in there and we look at carbon. We can see that for carbon, the atomic mass is 12.01. So that's how you calculate the atomic mass, and that's what these decimal numbers are at the bottom of the periodic table. It's kind of interesting because no carbon atom in the universe actually weighs 12.011. They all either weigh 12 or 13, but the average mass is 12.01. So now that we talked a little bit about atomic mass, and we saw an example of that, I just want to make sure that we're all clear on the differences between the terms atomic mass, mass number, and atomic number. Because these are terms that students tend to mix up, and as a chemistry professor, I know chemistry professors like to make sure on the first exam that students really do understand the difference between atomic number, mass number, and atomic mass. So let's take a minute and go through these three terms and make sure that we clearly understand the differences between them. So we already talked about the definition of atomic mass, weighted average mass of all isotopes for an element. But these other two terms kind of sound similar to atomic mass but have very different meanings. So what does the atomic number mean? Well, the atomic number is simply the number of protons in an atom. And then what does the mass number mean? Well, the mass number is the number of protons plus the number of neutrons in an atom. So even though these three terms sound similar, atomic mass, atomic number, and mass number, they have very different definitions. And trust me, professors love to test students to make sure that they understand the difference between these three terms on tests. So that's why I wanted to just take a minute, put all three of those terms up there and kind of have all their definitions lined up so that you can make sure that you truly understand the differences between those three terms and you do not mix up those three terms on your chemistry exam. Alrighty, that is it for this lesson. I hope you learned something, and I will see you in the next video.